All right, welcome to King's Lessons. That is chemistry concept on ionic bonding. Yeah, so today we are looking at ionic bonding, and the teacher behind this studies is called King Solomon. King Solomon. All right. So with ionic bonding, when we see an ionic bonding, already in previous videos, we've already said that ionic bonding is a special type of what? Interatomic bonds. It is a special type of what? The interatomic bond. So anytime you hear an ionic bonding, it is characterized by the keyword complete transfer. Ionic bonding is always characterized by the complete transfer of electrons. Complete transfer of electrons from one atom to another. Atom. So when we say an ionic bonding, we are looking at the complete transfer of electrons from one atom to another, resulting in the formation of a two charged particles known as what? Ions. Resulting in the formation of what? A two charged particles known as ions, which are held together by the help of what? Electrostatic forces. So in ionic bonding, one of the key things you are supposed to know is what we call what? Electrostatic what? Forces. So we are looking at the complete transfer of electrons. Unlike for covalent bonds, we look at what? The sharing of what? Electrons. Okay, the sharing of electrons. One will bring some, the other will bring some. Right. Okay, but for ionic bonding, we are looking at direct complete transfer of an electron from one atom to what? The other atom. All right, so as ionic bond is formed, when one of the atoms can donate electrons to achieve what we call the inert gas electron configuration, and the other atoms what? Need to what? Needs the electron to achieve what? The inert gas electron what? Configuration. So we already said that anytime bonding occurs because we want to achieve stability, either the octet for any other that is the 8th valence electron, or we achieve the duplet, typically for what? Hydrogen and what? And helium alone. So now what happens is that if we have, let's say, atom A and atom B, and this atom is completely transferring this electron, which is this electron over here, and is transferring this electron to what? To B. What happens is that A has what? Donated the electron, and B has what? Accepted the electron. Now, over here, what we are trying to say is that the A donate electron and the B accept because all of them want to achieve the inert gas electron configuration. All of them want to achieve the inert gas electron what? Configuration. Now, the inert gas electron configuration is so just because of one thing: stability. We want to achieve what? Stability. So in achieving the stability, we are reducing what? The potential what? Energy. We are reducing what? The potential energy. That is to achieve what? Stability. So now the one that donates the electrons become positively charged. The one that donates the electron become positively charged, and the one that accepts the electron becomes negatively what? Negatively what? Charged. The one that accepts the electron becomes what? Negatively what? Charged. Okay. Now that is when we see a chemical bond formed by the transfer of electrons from one atom to another. Ionic bond is also known as electrovalent bond. So anytime you hear the term ionic bond, it's also referred to as what? You can keep that in your head. It's also referred to as what? Electrovalent bond. And compounds composed of ionic bond are called what? Ionic compounds. So when there's an ionic bond within maybe A and B, then A and B now becomes what? A compound. Okay, so A becomes positively charged, B becomes negatively charged. When we form the compound AB, we can call it what? Ionic what? Compound. Therefore, it would be wrong to say that ions form ionic compound. So it is wrong to say that ions form ionic compound. No, we don't say that. When a metal reacts with a non-metal, That is, in this case, A is a metal, B is what? A non-metal. So when they react, then they form ionic bond. And the compound is called ionic compound. So we don't say the ions will form what? Ionic compound, no. It's the metal reacting with a non-metal. When they react, the compound that is formed is called the ionic compound. So the bonds, which are the ions, begin to what? React. The ionic bond, leading them to form what? The ionic compound over here. All right. And what keeps, when they form a compound, what keeps them is what we call what? The electrostatic what? Forces. Electrostatic forces. So as we go on, we'll look at what? The electrostatic forces very well. Now over here, let's look at a typical example. That is the formation of what? Sodium chloride. Let's look at a typical example, the formation of what? Sodium chloride. All right, so we are looking at the formation of what? Sodium chloride. So over here, when we say sodium, sodium is what? An element or an atom with an atomic number of what? 11. Sodium has an atomic number of what? 11. And chlorine has an atomic number of what? 17. So now, if you write the electronic configuration, you realize that sodium is 1s2, 2s2, 2p6, 3s1. This is for sodium. All right, so let me use the black marker for chlorine. So chlorine is 1s2, 2s2, 2p6, 3s2, 3p5. 3p5. All right. So now these are the electronic configuration. So if you look at this over here, with a principal quantum number 3, it has what? 1 electron. So the valence electron here for sodium is what? Is 1. If you look at here, the principal quantum number 3, it has how many electrons? 2 and 5. So the valence electron here is what? It's 7. Okay. So now, if you are comparing the Lewis-Dot structure, what happens is that if you write sodium, it has the Na chemical symbol represents what? The core electrons, and the dot represents the valence electron. The same happens to the chlorine. The core electrons, which is 10, represented by the chemical symbol, and the dot represents what? The valence electron. So now, in ionic bond formation, what happens is that the 1 electron here, okay, is being transferred over here. Okay, the 1 electron here is being transferred what? Over here. Now, this transfer of electron is what we call what? Ionic bonding. So when you are done, you realize that the sodium will be left alone, and the chlorine will receive 1, 2, 3, 4, 5, 6, 7. And the electron that came from what? The sodium. I get it. So this is what the chlorine what? Will be receiving. So now, over here, the chlorine has achieved an octet. The sodium has also achieved what? An octet. So the sodium here without these electrons is now what? Only 10 electrons, which is what? 2, 8. It has received the octet. Now, the chlorine also too with this electron has received what? 2, 8, 8. It has received what? The octet. Okay. So now the chlorine here is stable. The sodium also here is stable. But because the sodium here lost an electron to the chlorine, it becomes positively charged. And because the chlorine here gain an electron, it becomes what? Negatively what? Charged. It becomes negatively charged. Now, the problem here is that when you look at them, there's a concept we call electronegativity. Okay, anytime you say electronegativity, we say it is the ability of ability of an atom to attract the bonded electrons more onto itself. So now, this is an atom. So chlorine is highly electronegative than sodium. Chlorine is highly electronegative than sodium. That is to say, when it receives the bonded electron, it attracts the electrons more onto itself. All right, so now take note. These electrons here, okay, that did not take part of the bonding, they are called lone pair electrons. And the electron here that took part of the bonding is called the bonding pair electrons, the bonded pair what? Electrons. So now what happens here is that because chlorine is highly electronegative, when we are done, the chlorine pulls the bonded electron more onto itself. The chlorine pulls the bonded electron more onto itself. And when that happens, it creates what we call what? Electronegativity difference. Electronegativity what? Bond difference. Electronegativity what? Difference. All right. All right. So now we want to explain the properties affecting what? Ionic bond. High explanation. Yeah. And first, one of the properties we are explaining firstly is what? The melting point. The melting point. So what happens to the melting point in ionic what? Bonds. All right. So now, because of the many simultaneous attraction between what? Cations. So there's a cationic reaction and there's an anionic reaction. When there is what? So the cationic and what? Anionic. So the reaction that happens between the cations and the anions, okay, we realize that ionic crystal lattices are very strong. I getting it? So when the bonds are formed, this is something that happens. I getting it? There are crystal formations, and these crystal formations over here, okay, are very strong. These crystal formations over here are very, very what? Strong. Now, the process of melting an ionic compound, okay, the process of melting an ionic compound requires the addition of large amount of energy to break all the ionic bonds. Do you get it? The crystal formation that has been formed, that is creating the ionic networks, in other words, the lattices, they are very strong. So if you want to melt this particular compound, you realize that you will need larger amount of what? Energy. Do you get it? You will need larger amount of what? Of energy to break it. The ionic bonds from what? The crystal. So for example, you realize that the sodium chloride has a melting temperature of what? 800 what? Degrees. That is, you need an energy of what? Close or above 800 what? Degrees before you can melt what? A sodium what? Chloride. Do you get it? So in short, what do we say? We say what? Ionic compounds, they have what? Higher melting point. They have higher melting point. And this is the explanation. Because of the ionic crystals, it takes a lot of energy to break the bonds that happens, the ionic bonds in what? In the crystal. So they have higher melting point and higher boiling point. All right. All right. So now let's look at the point 2, which is the hard and what? And brittle. The hard and brittle. Now, ionic compounds generally are hard. Okay. Ionic compounds generally are hard because of what? The lattices, the ionic networks that are formed, and the crystal lattices that are formed as well. But they are brittle. Why? Because it takes larger amount of mechanical forces, such as striking a crystal with a hammer. I getting it? So before you can shatter, that is the principle of what? Shattering. Do you get it? For ionic compounds, it will take a very large amount of mechanical force. Okay? That is, before you can force one layer. I getting it? Maybe these are layers that are formed, crystal layers that are formed, the bond existing between them. Before you can force this layer A out, you take a larger amount of what? Mechanical force, such as striking with a hammer, before this layer will be able to what? Leave, and this bond will be able to what? To be broken. You get it? So now, what happens is that when you force this layer to move, mostly it shifts to relative what? Neighbor. So the bonds are like this. I get it. Plenty. So C, D, E, F, G, H, I, G. So now when you're able to remove this from this particular bond, the moment this one slips, maybe it attaches itself back to what? To the gene. Are you getting it? It attaches itself backward to the gene. So we say it's what? Very hard and it's what? Very brittle. However, when you're able to remove it, strike it and remove it, it brings ions of the same charge next to what? Each other. So the repulsive forces that exist between light charged ions cause crystal to what? To shatter. So for instance, if this particular here was negative, okay, and the A that is coming is also negative, the moment you shatter the A and break this particular bond, obviously this one will be positive. The moment you shatter the A and break this particular bond to this place, you realize that the light part, the light charges, A negative and the G which is negative, they'll repel. Are you getting it? So there'll be a repelling force, no attraction. And that's how come the A can be taken away from the crystal lattices. And when an ionic crystal breaks, it tends to do so along smooth planes because of what? The regular arrangement of what? Of the ions. So this is what happens and makes what? Ionic bonds or compounds very hard and what? And very brittle. So the next one we look at is the conductivity. I will say the conductivity. The ionic molecules in aqueous solution or in the molten state are good conductors of electricity. So now, the typical example is that before this particular ions, which have created a crystal, I get in it. So for instance, maybe sodium, chlorine, sodium, chlorine. These have created what? Crystals. I get in it. So before these compound can break or can conduct electricity, you have to put this compound, the whole solution, in what? In the molten what? State. So now, when they are in their solid state, it cannot conduct. It cannot. I getting it. But when they are in the molten state, when you put an aqueous solution around it and it's in the molten state, they are good conductors of electricity. And this is due to the presence of what? The ions. So the presence of the ions over here will now act as what? Charge carriers. Are you getting it? The presence of the ions in the molten state, when you put the ionic compound inside an aqueous solution, the ions over there will begin to act as what? Charge carriers. All right. And the last one I want to talk about is the lattice. Okay, I should have talked about the lattice before all these things. So now, with the lattice, what happens is that ions are atoms or molecules. So anytime you see an ion, it's either it is an atom or it is what? A molecule. Which are what? Electrically what? Charged. So if a molecule is charged, it is what? An ion. If an atom is charged, so you can have an atom like sodium plus, which is an ion. You can have a molecule like SO4 2 minus, which is a molecule, a radical, that is also what? Charged. So it makes it what? An ion. All right. So now, what happens over here is that ion is an atom or a molecule that is what? Electrically what? Charged. So the cations are positive, the anions are what? Negative. All right. Now, when ions form, when an atom gains or loses what? A valence electron. So we say the cation, that is the atom loses electron, the anion, the atom what? Gains what? Electron. And the bond between them is the ionic bond. Okay. All right. So since electrons are negatively charged, an atom that loses one or more electrons will become positively charged. That is the cation. And the one that gains one or more electrons become more negatively charged. So what happens is that these opposite charge ions, they attract each other to form what we call ionic networks. So these ones, they attract. Okay. So there's an attraction that exists between them because this one has formed positive, this one has formed negative. Are you getting it? So the attraction that between them form what we call the ionic networks. And this ionic network is what we call what? The lattices. Are you getting it? This ionic network is what I call the lattices. So positive, negative, positive, negative, positive, negative, positive, negative, positive, negative, positive, negative. It creates what we call what? A lattice. Are you getting it? A lattice. And this lattices, you can explain their position very well by electrostatics. Okay. So we say electrostatics explain why this happens. Opposite charges and like charges, opposite charges will attract, but like charges will what? Will repel. If it's positive, positive, they repel. Negative, negative, they repel. But if it's a positive, negative, they what? Attract each other. That is what? The electrostatic what? Force that is beneath that, influenced by the Coulombic what? Law. And the Coulombic law states that if you have what? The energy for electrostatic is equal to what? Is directly proportional to the quantity of what? Their charges, and inversely proportional to the internuclear distance between the particles, which is R. Internuclear distance between the particles. Are you getting it? So this is the formula for what? The electrostatic what? Force. This is the formula for electrostatic what? Force. When you are looking at charges over here. So now, you know how the lattices are formed because of the ionic what? Networks created between what? The positive and the what? Negative what? Charged atoms or what? Or molecules. Charged atoms or what? Or molecules. Now, what happened here is that the properties of ionic compounds follow from orderly arranged crystal lattice, which are tightly bound. So the key word over here is that these crystal lattice that are arranged over here, they are tightly what? Bonded. Okay, charged particles that make them up. And the ionic compounds tend to have high melting point and boiling point, which I've already dealt over here because it takes higher energy before you can break this particular what? Bond. Yeah, because it takes higher energy before you can break this particular bond. And the attraction between the lattices, I get in it, is very strong. Now, moving an ion, if I move this particular ion here from this lattice, let's say I move this particular ion here from this lattice, it distracts the structure. Are you getting it? It distracts the structure. So, for instance, if I have this positive, negative, positive, negative, positive, negative, this crystal lattice, okay, and I take this particular ion out, you realize that I'll be having a structure like this. Are you getting it? I've taken that structure over here, which is this part, over out. And ionic compounds will tend to be brittle than malleable. So this is the reason why when you take the structure out, it tends to be what? Very brittle. Are you getting it? And not what? Malleable. It tends to be brittle and not malleable. And ionic compounds do not conduct electricity in a solid state. When it's in the solid state like this, like I said, it can't conduct electricity unless you put it in what? A molten state. Because if it's in a solid state, the ions cannot move freely. So over here, ions cannot move. So the key word is that it cannot move what? Freely. But the moment it gets into what? The molten state, they begin to move freely. Okay, they dissociate into what? Individual ions, and they move freely, therefore causing conductivity of what? Electricity. Are you getting it? So here, they need to what? In the molten state, they need to move. They need to move what? Freely. That's what happens. They need to what? Move freely. All right. So these are the properties of ionic compound. The properties of what? Ionic compound. So now we say what? One, they have higher melting point. They are hard and brittle. They conduct electricity in molten state, and they have what? High lattices. That is in terms of what? Their strength. All right. So thank you for joining me on this particular lesson, and we shall meet to discuss covalent bonding in the next video.